in the next lesson. So here, if we have a look, we've got light passing through a concave glass block, and light comes in parallel and then diverges away. And if we extrapolate backwards, we can see that the light appears to come from here. If we did not know, if we were looking from this side and we did not know what was happening here, our brain would process it as if the light originated from a source over there. So how does a lens work? I've briefly discussed this already. However, if you look at a convex lens, we know it's pointy at the top in this region here, similar to a triangular shape at the top in this region here. So if you have light rays coming in, let's say parallel, so we had 4 torches, 4 ray boxes, what will happen is light will hit the surface, refract, bend towards the normal and bend away from the normal, and we get a refraction on entry and refraction on exit. But that effect gets less and less as the ray of light approaches the center. Now, this is very similar to a convex lens. And here we have 2 triangular prisms facing point inwards, showing a concave lens, thin in the middle, thick on the outside. And the same way, light, what will happen is enter and it'll bend away from the normal as it exits, bend towards the normal on entry. Now here is another picture. Each segment of the lens is split, and we can see how light will refract through each segment, and when it's brought together, you get the overall effect as we have discussed. Now, what I would like you guys to do is, can you draw what will happen when light passes through A, B, C, and D? Okay, so draw light rays passing through A, B, C, and D. So you got a thin lens, a thick lens. How do you think the rays will change? Here, what we've got is light rays coming in parallel, and we've just discussed this lesson. Here, the light rays are originating from the focus point. So have a think about that. And here we've got rays coming in parallel, entering a concave lens. Now pause the video, have a go. The answer to the question is shown here, where you've got the first ray coming in parallel, second ray coming in parallel, third ray coming in parallel. And we know when that happens, the light rays converge at some focal point. Now, you did not know, I did not give you what the focal point was, so you just needed to converge at a particular point. Ray B, object B, is thicker. Because it's thicker, we expect more refraction, so more bending. So the rays will converge at a closer distance compared to this distance here for the thin lens. So that distance where the rays converge is closer. Part C is the challenge question. If the rays originate at the focal point, it's the same as A but in reverse. So it's originating from here, the light rays are coming out that way, and they will come out of the lens parallel. So the path the light takes will be the same regardless of which direction it's going. So if light rays originated from this point here and took this trajectory, they will come out parallel on the other side. If they came from the focal point and hit the lens, they will come out parallel. And finally, we have rays diverge away as they leave the diverging lens. By how much they diverge away, it's up to you right now. I'm not going to be very strict on how you're going to do this because I have not given you the focal point of this diverging lens.